Hello everyone, welcome to the first episode of this multi-part video series on NSX Advanced Load Balancer, also known as AVI Load Balancer. My name is Satya Shrestha, a senior staff multi-cloud solutions architect here at VMware. And together with me, I have Kumar Mittal, who is NSX Advanced Load Balancer expert at VMware. Welcome, Kumar.
Hey, hi Satya. Thanks for introducing me. I'm Kumar. I am NSX Advanced Load Balancer expert at VMware, and it'll be good to chat with you regarding the capabilities of this revolutionary product.
Today in this video, we'll cover current landscape around load balancer and how VMware NSX Load Balancer can help in modern application delivery in multi-cloud environment. So Kunal, why don't you take us through what we have?
Oh, sure. Let's get cracking.
Okay, so in today's modern multi-cloud world, how do you see application landscape changing?
Satya, the applications today are delivered in a multi-cloud platform, which can be on-prem, on public cloud, in a microservices container environment. And since COVID, organizations has embarked on a multi-cloud journey where majority of the organizations, as you see, are in nearly 5 different cloud platforms. So as a result, the application resides in different environments. And for application delivery, load balancers has been key to provide application resiliency, not within a single environment, but also across multi-cloud environments, when it comes to geo-redundancy of the applications. And that's where load balancers are key for application delivery. And that's what we are going to talk in this particular talk.
84% of the enterprises there, they have multi-cloud strategy, and they are doing that in multiple clouds, right?
Correct. This is the data that is actually taken from 2019, the Forrester Cloud Research report. But then this has actually grown to 87% in the latest report that I was just browsing today in the morning.
Got it. So with this multi-cloud environment, and as you just mentioned that, they are using so many clouds, 5 in average, how does the business deliver the application today in multi-cloud environment? And what are the challenges today's business face when it comes to application delivery?
Great question. That actually takes me to my next slide, Satya. The applications are key to the business. Rather, I would say applications are business in itself today. And IT houses, they want to deliver the applications as fast as possible. And agility is the key over there. But all that agility and deployment of the application actually comes to the same amount of teams, which are still static. They're not growing rapidly as the application landscape is growing. And they have to go and manage those applications now, not just manage, but also go and deploy them across the multi-cloud environment. And key to that agility and to the application delivery has been in automation. A lot of automation, the advancement in automation space that we have seen is primarily into the compute, storage, and network space.
Right.
Whereas the load balancers are still static in nature. You still have to go and raise tickets, and manual configuration changes have to be performed on the load balancers, which kind of become the key blocker towards the agility of application delivery, which businesses are looking at.
Yeah. So when you say static load balancer, are they mainly hardware load balancer? What are these static load balancers?
When I say about static load balancers, these are primarily the traditional load balancers that we talk about, which can be hardware, where we have been deploying the hardware load balancers in on-prem data centers from quite a while in an active standby fashion, where standby pair it's a good old friend so that it can take the load in case the active is not available. But then if you see, there is an unused capacity which cannot be utilized. When these hardware load balancers were deployed, they were deployed with the thought process of next 3 to 5 years. Over provisioning that was done in case more is required in the future. But does the businesses and applications grow at that pace? And majority of the time when we go and talk to the customers, what we see is that they are only being utilized 15 or 30%. So even in the active pair, there's a lot of unused capacity that is sitting idle and locked.
So the active load balancer itself is only being used for 15% of the time. And like you said, standby is just a standby sitting doing nothing. And only when the active fails, that will become active and then it will start taking load, right?
Exactly. And this is just the tip of the iceberg.
Yes.
If I actually proliferate this out into the data center space, and when we are deploying VMs are basically nothing but the same code base and the image that has been derived out of the hardware load balancers, and we have been deploying them across our data centers into our public cloud with the same active standby architecture. So what it actually led to is a lot of load balancers that have to be managed, if you see up over here.
Yes.
But with the same architecture, there's a lot of all these gray squares that you see are locked capacity. And even the VMs are being provisioned with that same over-provisioning mindset, due to which the unused capacity is low. The simple question that arises over here is, do we require so many sandboxes? Can't there be an intelligent way where we can do a true active, or we can have 3 active and 1 standby? So that we don't have to do all that costly over-provisioning of our application delivery platform? Or can there be some sort of capacity pooling so that if I have the unused capacity, I can take it where it is actually required instead of bringing my application traffic and do a hairpinning of that traffic from the platform itself?
Yeah, looking at what you're showing me, it looks like a lot of waste there. And then the resource being underutilized, where it could be efficiently utilized, right?
True. What it also causes the operational challenge, because these are all separate control points.
Right.
It has to be managed as a standalone itself. The other operational complexity that comes, it is simple lifecycle management. Even if you have to do a patch management or an upgrade on these devices and maintain the same code base, just think about how much amount of operational overhead that it brings, because they are key to the business application. It sits in front of the business application too. In order to upgrade them, there's a beeline of application developers that have to sit during the night just to perform the testing when the upgrade happens.
Yeah, exactly. I mean, this plethora of devices sitting in there, when you need to do upgrades and patches, you will need to absolutely think about what is application sitting behind it. And then all those application developers need to start testing everything, right? So I can imagine how the overload is going to be with all of this.
True, absolutely true. And that's where we say they are not actually designed for the modern new environments. They were good for our static data center environments, but in the new world where we are looking for more agility, scalability, and elasticity, these are still static boxes which cannot scale.
Yeah, exactly. And the other point is today's infrastructure is mainly written through code, right? Infrastructure as a code. Now, with these virtual machines, I could also imagine there could be a challenge around that. What is your view on that?
Oh, absolutely. That's where what we see is that there is public cloud native tools that are becoming popular. And on the landscape of application delivery, there are east and west set of application delivery platforms that we see. On the west, if I talk, are the public cloud load balancers, which are native to their public clouds. They offer great scalability. They are automated to their environments. We have Azure native tools, AWS native tools, Google Cloud native tools. But the challenge that we see is no matter how much amount of scalability, automation capability they provide, they are static and they are very locked into their environment.
Right. So they're limited to their own particular cloud environment, right? Even if they've operated really well in that environment, they may not be suitable for a multi-cloud environment, right?
Exactly. I mean, if an organization is on a multi-cloud journey, then they will have to maintain separate talents and have to train their IT staff on all the separate and distinct tool sets of the clouds that they are imbibing. And it causes a lot of operational overhead. Then the second set of challenges, these tool sets are good in what they do. If I have to back my statement, in AWS, there are a set of load balancers. There is a network load balancer, which is a layer 3, layer 4 load balancer. There is an application load balancer, which only does an HTTP, HTTPS, and FTP traffic. Then there is a gateway load balancer, which is for service insertion and redirecting the traffic to the firewall or the IPS for any third-party tools. Then for WAF, you need separate service altogether. For container ingress, a separate service altogether. IPAM, DNS, and Route 53 are all separate. And a lot of stitching has to be required.
Yes. You're talking about AWS ICC kind of thing happening in all cloud providers, including
Google. Yeah. Exactly. And visibility and getting telemetry out of it is a separate ballgame where a lot of resources have to put and do that development into CloudWatch and AWS in itself to get the real-time telemetry of application performance.
Yes, telemetry is used, and then again, that's another meter, right? So everything you have to pay for, every metrics there. The cloud bill becomes enormous when you stitch all of this together.
Correct. And that is the reason that even the legacy load balancers have found their way into the public cloud domain. You would see people deploying their fair share of legacy load balancers that they have been trained, they have been using. Why? Because they are rich in features. They are enterprise-grade, enterprise-ready platforms. The only thing that they lack is operational simplicity that we have talked about in the previous slide, automation, and the cloud-native capabilities, because they cannot elastically scale. If more is required, you have to spend more VMs and destroy the previous ones and do a lot of stitching, etc.
Exactly. So on this point, I know that with my engagement with my customers and partners, I see huge challenges in public cloud space, when especially delivering this kind of multi-cloud application, right? In multi-cloud environment, of course. So how is VMware really addressing the application delivery challenges?
VMware actually acquired AVI Networks in 2019. So AVI is a software-defined load balancer, which provides a consistent layer 4 to layer 7 enterprise-grade application services across multi-cloud. It is actually built on software-defined architecture, and AVI was born in 2012. And in in 2019, VMware looking at the great capabilities that AVI has in delivering applications across multi-cloud platform. And when I say multi-cloud, the two circles that you see over here on the left-hand side,
yes,
are all the well-known public cloud platforms and even the container platforms where AVI can actually go and integrate into. And since 2019, since VMware has come in, there is a lot of synergy that has been built where AVI has been integrated into the VMware platform. So it is a platform which NSX Advanced Load Balancer is a platform which is infrastructure agnostic. I say it can actually go and integrate into any environment.
So it can be deployed on any cloud, as we can see here, Azure, Google, AWS, even OpenShift, even for container environment, right? And also, I know that it can be deployed even as a bare metal, isn't it?
Yes, correct. It can be deployed as bare metal into your environment so that you can achieve maximum performance out of it. And it is enterprise grade ready because you require all these services that are highlighted on the left-hand side for your server load balancing for application resiliency in your data center. But for geo-redundant applications, you require DNS-based load balancing, which is provided by global traffic management. Now, security has become an important paradigm. Web application and application security is an important feature set that each and every enterprise is looking for. And NSX Advanced Load Balancer provides the enterprise-grade web application firewall and application security feature set. And
all these features we discussed here: local traffic management, global traffic management, web application firewall, Wi-Fi app security, container egress, analytics, observability, DNS, IPAM. All of these are really interesting features, which we will be covering in our further future sessions, right? Because this is a multi-part video series and it's just an introductory video today, but we'll be covering all of that in the future sessions, isn't it?
Oh, absolutely. We'll cover all of them in a lot of detail and depth. And when we get into the detailed sessions of how to configure the applications, we'll touch on each and every one of them. But one of the most interesting one I would also like to talk about is, how do we automate the application delivery? So the punch word that we actually use, which has become a buzzword, is that through NSX Advanced Load Balancer platform, you can deliver any application across any cloud using a single platform. That brings the operational.
I like that message. Deliver any app on any cloud with just one platform, which is NSX Advanced Load Balancer, right? Yeah, I like it. And we're going to demo exactly the same thing, isn't it, in our future videos?
Oh, yes. But not just future videos. I'll show you a glimpse of it today.
Okay, yeah, that'd be good if you can see, like sneak peek preview of, what we have. Yeah, Excellent. So tell us about the architecture of NSX Advanced Load Balancer. How does it look?
Oh, yes. The essence of the NSX Advanced Load Balancer, when we say that it is a distributed architecture for multi-cloud application services, actually lies in the software-defined principles of separating the control plane with the data plane. And based on those same principles of software-defined networking, the AVI controller is control plane and the brain of the complete fabric. Whereas down there in the data plane, the orange hexagons that you see, we call them as service engines, but you can say them as your load balancers app, which sits between the client and application traffic.
Right.
So the service engines are your traffic haulers and also the point of applying security controls.
Got it.
The flexibility that it actually provides is that now the service engines can be spent across any environment, which can be your on-prem environment, can be your public cloud environment. They can be deployed in any form factor. It can be a virtual machine, it can be a containerized service engine, and it can be in the bare metal environment. As a result, and what I would like to point is, when the service engines are ephemeral components. When I say ephemeral, what we care about is application presence. If your application is present, your service engine will be deployed. If your application is not available, then you don't need that particular resource to be deployed and all your other underlying resources to be consumed. The controller would actually remove that service engine from that environment until.
So the service engine in the world of cloud, so it could be considered as cattle, not the pets, right?
Yes, absolutely. That's absolutely right analogy that you have gone and used. As our pets, we have always gone and named them, kept them, and bred them to be our friends. Same has been the load balancers, where I remember in my past life, and I used to go and deploy load balancers. I've named them. I've even slept with my load balancers in the data center the night when I'm deploying them.
Right.
But then this is completely different analogy where, do we want to work for the technology or do we want the technology to work for us is the whole question.
So it's like up and down as needed, right? So It is very, very elastic. Yeah, I like that.
So I'll just unlock key features that this kind of architecture provides and the benefit it provides. First is central orchestration, where as I said, the controller is the brain of the complete system. When I say brain, literally I meant that. Why? Because a system admin would always log into the controller for its, for the deployment of the application, for its daily operational requirements, and even for troubleshooting. It would never require to log into a service engine.
Right.
And that's where the controller controls the complete fabric. It actually integrates into different environments, sees where the application is getting deployed. It will go and deploy the service engine into that environment by spinning a VM or the container and plumbing the interfaces into the right VLANs, deploying the application on top of it, allocating it an IP address, allocating it a meaningful name, and your application is ready. It is very different from the central managers that we have seen out there who manage a multiple set of load balancers. The difference is the central manager is basically only a configuration manager.
Right.
The system admin performs its day-to-day function still on the box, onto the load balancer itself. And that's the key difference. And a central orchestrator, a system admin would always log in into the controller, and the controller would have a complete view of the fabric, and it would also control it.
Right. So all the management of the data plane, which is service engines, are done through the controller. Is that right?
Absolutely. Yeah. That's the key. As a result, what it unlocks is that it makes the data plane elastic. In case more throughput is required in the future, as the business grows, as the application grows, you can actually spin more service engines in a horizontal fashion.
Right.
And what it helps also in running is that now we can run applications active. So your application in an elastic fashion can actually scale from a single service engine to up to multiple service engines.
Oh, nice. This
is
the challenge we saw earlier, right? The active standby and all the resource utilized, and that was not that great. Yeah, okay.
Correct. But the business benefit that it brings is you don't have to over-provision thinking of next 3 years or 5 years. You can start by sizing an environment, what is required today. And then you can keep on adding as the requirement grows in the form of more applications or more throughput that is required. So no more over-provisioning, no more wastage of resources that are required.
There's just-in-time provisioning and on-demand provisioning.
On-demand provisioning, and you don't have to replace the fabric. You just keep on adding into it.
Yeah.
From the resilience perspective, because the controller being the brain of the complete data plane, in case a service engine is impacted, it could be multiple underlying reasons, and your application has been impacted, the controller would automatically spin a new service engine, dynamically move the application from the existing service engine to a new service engine or another set of service engine which is performing well.
All right.
And then it will do its own voodoo and magic to self-heal itself. So it's a self-healing fabric. The key is we care about the application. Yeah. So coming back to your analogy of cattle versus pigs, the important part is the key in this whole thing is the application.
Yes.
So what matters is application delivery. And once the application delivery is being handled perfectly, then it can work to self-heal itself.
Right. So we talked about the service engine auto-healing. What happens if that similar kind of thing happens with controller? If controller fails, is it also resilient?
So yes, the resiliency of the controller is in the architecture and the design. And what we recommend actually in that way is running a 3-node controller.
Right.
Because controller sits out of band, it does a lot of other functions of analytics, which is another great feature, which I would show you onto the demo.
Yeah, sure.
In case a single node of the controller dies, then there are other 2 set of nodes that are available, which can handle the load from the analytics perspective, from the management of fabric perspective. So that's where we recommend running a 3-node architecture.
Okay, so it's mainly around how you architect it to make it more resilient, right? Got it, yeah.
Correct. Another great feature is automation. Automation being key to today's scalable and agile world of public cloud.
Yes.
That's where the architecture of NSX Advanced Load Balancer fabric is based on REST API. The REST APIs are exposed, and that's to be used in an infrastructure automation and the operational automation. When I say infrastructure automation, with the REST APIs, we have actually done an API integration to deliver the load balancers and the virtual service in an automated fashion for controllers to be integrated into those environments. So the APIs are available for all the well-known public cloud environments, your AWS, Azure, GCVE, AVS, VMC, we have all those are supported APIs. And as a result, controller can now go and connect into your subscription, your account, get a view of the VPC on the virtual net in Azure, and then actually go and, as you deliver the application, it can spin up an EC2 instance in AWS, plumb it into the right VPC, right subnets, allocate the IP address, and as your application is getting delivered, your load balancer will also be delivered and virtual service placed on that application. And it would, at the same time, it would also go and integrate and allocate it a dynamic name and publish it into Route 53.
Right. So what you're saying here is AVI has the capability of REST API, not just within itself, but also to call REST APIs from other cloud vendors like AWS, Azure, Google, etc. And it can integrate really tightly with them and then spin the resources, not only within the AVI ecosystem, but also in the cloud provider, and then spin up any services or any resources it needs. So the application is resilient and it's also robust. Is that right?
Exactly. You actually nailed it on the head.
Got it. Okay. Yeah, I like it. I mean, REST API is everywhere these days. The developers, they are creating their application on REST APIs, and even the infrastructure vendors like us, we actually create REST APIs even before we create the UIs, right? So they can just invoke the command, they can just use the REST API, and then they can use the functionality as they need using the REST API. And it's interesting to hear that AVI is capable of doing all of that.
Yeah, and on top of it, the REST APIs are also exposed where you can actually perform your day 0 to day 1 and day 2 functions using all the well-known automation tools like Terraform, Ansible, Swagger, RE automation, etc. And there's a rich library of automation that is available on VMware GitHub.
So talk to me about the analytics. I know that AVI has excellent analytics and observability. Tell us, what is its capability there?
Analytics is key, man, and it is great. I have done a lot of load balancing in the past, but when I saw AVI Analytics, I was amazed. And how it does it is also based on the software-defined architecture of it, where service engines, which are down there at the data plane, sit between the client and application traffic because they see the complete transaction between client and application. If it is layer 4 or to the layer 7 traffic, they can actually extract nearly 700 metrics out of that data and feed it back to the controller. Now, controller sitting out of band to the traffic, it can actually use its computational power and resources to stitch that particular logs or the metrics that has been collected. And with the AI and ML that we are running behind, can present the logs not just in a very human readable format, but what it actually gives is the real-time application performance, how your application is performing, and also client experience. What is the client experience in accessing that application, which is key to the businesses when they are as they want their applications to be accessed by the clients as fast as possible.
Now, I know we're going to cover all of this in more detail in the future, but I'm really interested to see, what you just discussed. Can you actually demo us like a sneak peek preview of how it looks like in AVI Console?
Oh, absolutely.
Advanced Load Balancer Console. Yeah.
Okay, so we are here in the console of AVI, and this is how the console looks like. And when I say console, this is the controller. The login to the controller is actually, you can control it through single sign-on. My login to the controller is actually being controlled through single sign-on through VMware Workspace ONE.
Got it.
On the right-hand side on the top, if you see, I'm running multiple controllers across
places.
The globe.
All around the world. Yeah.
But I can actually go and manage all of them through a single window.
Nice.
Then also on the left of it, what you see over here are different tenants. At the moment, I actually logged into the admin tenant.
Yeah.
All these ones are the different tenancies where my application and my virtual service reside. Why I want to show it over here is, before I even start diving into the analytics, is how operationally easy we have tried to make it. In terms of multi-tenancy, which people are aware into, as different subscriptions they have or different accounts that they manage in AWS and different tenants that they manage. Similarly, you can create multiple tenants within AVI controller and lock it based on either your business units or your application units within businesses. And with the granular rollback access control, you can actually hand over the management of your virtual service to your application teams directly.
All right. So there's such a level of granularity where you can allocate it per department or per business unit or even per teams, and then also give them access to that particular resources on that tenancy, right? I like it. Really good.
Oh, exactly. I mean, and why is that key or interesting to the organizations is because for even a small change, when, for example, the application team is just making maintenance to its web pages and they need to redirect it to a splash page. They need to change the request with the network team to make the change on the load balancer. And it has to go through multiple processes of doing it. Why can't the application teams do it themselves? And with this simple rollback access control and delegating that function to the application team themselves, they can manage that change.
It's all self-service. They can do everything themselves, depending on what we have given them the permissions, right? I like that, man. Awesome. Okay.
Let me go into my demo tenant where my multiple applications are being configured. And very first thing when I said I'll show you the glimpse of MultiCloud application delivery is right here, where I have my application, my AVI demo application, which is in a vCenter environment and on-prem DC. But my next application is hosted in an AWS environment. My third application is hosted in an Azure environment, and I'm all managing all these three applications through a single controller and delivering them as well. So, and this is configurable. At the moment, my controller is integrated into these three environments. As part of my day 0 function, I can go and integrate into Google Cloud, into other cloud platforms, AWS, etc., and deliver my application over there. We'll probably delve into that in our later videos, but let me show you the glimpse of analytics.
Yeah,
it starts right from here. So my AVI demo application, which is in a vCenter environment at this stage, the very first thing what you would see is is it is actually giving me a lot of information as to what this application is doing. I don't have to dig into a lot of different clicks and pages just to get information. What is this all about? If you see, this is an RV demo application, which is having a certain set of pools. I can see my pool members over here, and one of my pool members is down. But down over here, you could see, it is also doing some sort of content switching, where if it's doing upload, then if there is some sort of upload that is happening, then that is happening to a different set of pool member. And if there's some sort of images are being requested, then it is being redirected to a different set of pool member.
Right.
And one of my pool member is also not available. So what is happening there? So if I click here, then it gives me the health of my application. That's what I was coming to. Now, health of an application, when I say, usually it was binary, why it is available or it is not available. If it is not available, then there could be multiple reasons around it. And that's what we are trying to break that into 4 different categories and then give a health score to it. So the fourth, which is performance, how my overall application is performing in terms of what is the transaction rate, has there been any spike or anything. Then there is resource penalty, which is in case there is a resource that is not available. And what we could see right over here, one of my pool members is down.
Yes.
It will give me a resource penalty. Anomaly penalty actually dwells into behavioral analytics. So the controller over the period of time forms a behavioral pattern of the application in terms of what is the rate of access, rate of transactions for that is happening between client and an application for the traffic. What is the throughput? All that, number of open connections, etc. And in case there is a spike or a dip in that normal rate of transactions, then it will give me an anomaly penalty.
Okay, got it. So we have one host down here, and because of that, we can see some things on red in there, right?
Yes, correct. That's why you see something in red. And security penalty is in case there are weak ciphers, there is a expired certificate that is being transacted with the application, then RV controller can pick it in its analytics and would show you a security penalty. And based on an algorithm that is running, it gives an overall health score for that application, which in this scenario is 63, which is fairly good. It is not very good, but it is not bad as well.
Got it. So what is the full score? Is it 100? Or is there?
Yes, it is. It is computed out of 100.
Okay. Full score is 100. Okay, got it.
Correct. Now let me take you into the next level of analytics that I was talking about, and this is what I have been boasting about when we said it can actually give you an end-to-end application performance, but also the client experience in terms of accessing the application. So what it is stitching is an end-to-end time as to when my client accesses the application to the time that the packet has actually spent into my data center. So overall client round trip time in accessing the application, and what is the amount that has been taken by the server or the application or the backend data transfer that has taken place. And this is done over the period of last 6 hours. This is an average value of past 6 hours.
Got it. Yeah.
And if I move across my graph, this is actually shown on a real-time basis.
Okay. So you can see the actual performance and health metrics right there over 6 hour period here. Okay.
Correct. Believe me, this kind of analytics has been accoladed by our customers who have been using RV. I mean, they have praised it to next level, where it has brought a lot of operational simplicity and have helped them in faster troubleshooting of their simple issues like application latency.
Performance is everything these days, right? I mean, every millisecond counts, and I can already see here, just within this screen, that I can track down, hey, where is the bottleneck? Where is the problem in my application? I can see if there is issues with, for example, my SQL server, and that is consuming a lot of time during the processing. I can straight away see here, right? You can see, there is a app response time, there's data transfer time, there's issue. If there's an issue with server, I can see that as well. So this is really cool. I mean, you can pinpoint where the problem area is and then quickly troubleshoot it. I get it. Yeah, this is good.
No, absolutely, and I like to joke with with most of my customers who are using RV, because majority of and especially the network teams, because majority of the time whenever there is an application problem like latency in the application, it starts with the network team.
It's always a network problem. Yeah,
it's always a network problem, and that's where everybody has started calling this graph as mean time to, in a sense, for our DM network administrators. Why? Because now they can quickly tell that, hey, it was, in this scenario, this is not a network problem. It was a slow application response that actually caused this problem.
Yeah. So it's good time to innocence. Is that the metric?
That's what we call it now. This is means intelligence.
I like that.
And next coming videos, I'll actually delve more into troubleshooting, that it is not just about finger pointing, but how the platform can actually help in faster troubleshooting and pinpointing where the issue is.
So we had a quick look on your demo around analytics and some features around NSX Advanced Load Balancer. And this looks great. So what is our application-centric multi-cloud strategy with AVI Load Balancer then?
As you see, it's a powerful analytics-driven platform for multi-cloud services. And I said, in the demo when we saw, it's multi-cloud ready. So a single controller, through a single control plane, you can actually deliver your applications across any environment, which can be on-prem, your native public cloud, or your VMware public cloud environments. Mm-hmm. But all the enterprise class services that are required for application delivery and critical for their availability to the business, like your SLB, global traffic management, securing the application through WAF and application security, and even delivering the application with the same agility and elasticity in the container platform in a microservices world. All those features, application services features, are available through this platform. And the functionality of scalability, elasticity, self-healing, automation, analytics are also available through the platform. So as a result, now the businesses and IT teams can actually realize deploying their applications much more faster with operational simplicity, because now they don't have to learn and maintain different distinct set of tools and stitch them together. All that feature sets is available through a single platform. And then proactive support, which is provided by the controller itself. One, because it can detect misconfiguration, anomalous behavior, can do sizing and scaling.
Right. So this looks like really a universal load balancer that can be deployed on either your private cloud or public cloud, or even our VMware public cloud. And then with the central management, like you said earlier, with the central orchestration, we can orchestrate it, the service engine on any cloud, right? And then with all these analytics and all the interesting enterprise-grade features, you can quickly monitor, manage, and secure all of your application really, really quickly. This looks really great, Mark.
Oh, yeah. I mean, I'm always excited to talk about more and more features of it. But then the great part is you get all those feature sets as part of the single fabric.
Yeah, I know. The other thing is about licensing. I know licensing is a very nuanced and complex topic. Tell me about the licensing. How does that work for an NSX Advanced Load Balancer?
In VMware, I think we always talk about simplicity and making things simple. And following that principles, the license for NSX Advanced Load Balancer has also been kept very simple. With a single enterprise license, you actually get all the feature sets from application services to the features of software-defined platform.
Mm-hmm. Awesome, man. This sounds good. I'm really excited, to cover all of these advanced features in our future videos. But to wrap up this video, why don't you talk about what NSX ALB actually brings and what value it brings to our customer to make the application delivery easy?
Sure. It's not just me talking about this. This is something which has come from our customers, where they have been able to realize faster provisioning of the applications through automation and self-services that I kind of showed you a little bit. And what they say is that now they are able to deliver their applications 97% faster. Right. Compared to what they were able to do previously.
97% faster as compared to how they were doing before, right?
Absolutely.
And this comes directly from IDC's study, which is great.
Correct. We have done an independent study through IDC, which has published a great paper, and it takes in researching various ADCs available in the market and publishing a paper every year. And we have been on the top of the leaderboard in IDC studies from last 3 years.
Excellent. Okay. So how about that 41% less time troubleshooting? What does that mean?
That comes from the analytics and observability that I was talking about. And this is only a tip of the iceberg that I've touched, where in forthcoming videos, we'll touch on to troubleshooting, how to troubleshoot the applications. But the important part is that it is much more easier to reach the root cause, to analyze and the application latency or trivial application issue, or in case there is not a good client experience that a client are experiencing in accessing the application. We can quickly utilize the analytics of AVI and tell where the problem lies and help in troubleshooting and fixing that particular problem.
Got it. How about the TCO? I know cloud economics, etc., could be a separate topic in itself. Probably we'll do another video on that one itself. But yeah, what is this 30% lower TCO?
First, the TCO, the total cost of ownership, is calculated in different platforms, right from the CapEx cost to the OpEx world. And if we combine this together, we can actually do the real-time studies by plugging in the metrics of what you are actually spending on your load balancers and how you're utilizing today as compared to AVI. So with a software-defined architecture of separate control plane and data plane, first thing is controller is completely free of cost. And then with all the feature sets that come as part of the single fabric, you can actually manage your applications through a single fabric across multiple public cloud environments. You don't have to maintain separate set of people to maintain the applications across different environments. You can perform that operations through a single platform. All that combined together, it helps in reducing the total cost of ownership of your application delivery platform by at least 30%. But
yes, and also the
savings that are available, which we can realize and can show.
Right, and also the overhead we talked about earlier, that is already gone, right? So everything is active, service controllers, all the service engines are all on demand. So I think all of those will come into play here, isn't it?
Oh, yes. And just to add on that, usually on the question of scalability, AVI Fabric can process of nearly 1 million plus SSL transactions per second. In terms of competitive landscape, there's no business which is doing 1 million plus SSL transactions to that level. And also, it actually gradually grows over the period of time. And that's where the elasticity and scalability comes in, where the nearest competitors, which are still locked in a box state architecture, if your business grows, you would actually have to replace your box or your VM. Whereas with AVI, you just keep on adding. And you can scale horizontally to process, and you can keep on adding to process 10,000 SSL transactions today, and keep on adding to process 1 million SSL transactions per second in future. And plus, that would be amazed if your application and business grows to that level.
Yeah, exactly. I mean, 1 million plus itself is unfathomable. But it looks like a great feature set, and we can scale up to that. To know this is really great. So thanks, Kumar. All of these points are really insightful. I learned quite a bit myself, and I appreciate your time and your passion around showing what AVI Load Balancer or NSX ALB is capable of. So really appreciate that, mate.
This is only a start, Satya. There is a lot more to unlock, which I'm really excited to show you in the coming videos as we deep down more into the deployment and then unlocking the feature set, right from scalability, elasticity to disaster recovery. So all I can say is watch this space. There is more coming to learn on public cloud and NSX Advanced Load Balancer series. Thank you.
Absolutely. I'm super excited to see what's coming in the future videos. And of course, NSX ALB for multi-cloud environment, right? That's what we really want to see. Okay, everyone. So thank you for staying until the end with me and Kumar. And we look forward to seeing you in our future videos. Thank you and bye for now.